Hi, everybody. It's Mr. Rogers here. And I want to go over yesterday's work to make sure that we're all set. Yesterday was a unique day because everyone is a virtual student. And so I want to make sure that the lesson went well and we remember last week's stuff because it's been a long time. And also, we kind of got the gist of yesterday because yesterday is definitely a big building block day for us. And so we have to understand it. So, going through today's work. So first thing, explain what polarity is. Polarity is when a molecule has a charge. It could technically be a neutral charge as long as one side has a charge on the molecule and the other side has a charge. So water is like that. It has a positive charge on the hydrogens and a negative charge on the oxygens. So the two hydrogens on water are positive, the oxygen is negative. And because of that charge, they're going to be attracted to other things with charge. And hopefully, we know from our life experiences and other classes and whatnot that the negative charge of oxygen is going to be attracted to positive charges, and the positive charges are going to be attracted to negative charges. And so, water interacts with things that have a charge. We call things that have a charge polar, and the things without a charge nonpolar. And that's going to become a big thing this week. What are the six characteristics of water? So you guys had a six box sheet that should have been pretty easy to remember or to pull off of. The first one is cohesion. That's when water sticks to itself or would like to stick to itself. That creates surface tension. But cohesion is when water sticks to itself. Adhesion is when water sticks to other things, and water tends to stick on to polar things because, again, water is a polar thing. It likes other polar things. It has a charge and wants to connect to other things with charges. Next, we have high heat of vaporization. That is the idea that it takes a lot for water to actually become steam or to evaporate off. We use that when we sweat. The water on our skin is pulling heat from our bodies and slowly evaporating off. And that's taking the heat with it and that's cooling us down. So that's high heat of vaporization. Next one is high specific heat. It takes a lot of energy for water to warm up, and it takes a long time for water to cool down. Water is a great, what we call heat sink, and it takes in heat and it takes a long time to warm up. But again, reverse. Once it's warm, it takes a long time to cool down. This will come into effect with some of these other questions down below. Then we have questions like, or other characteristics like it's less dense as a solid, ice floats. And so that's pretty crucial for living things. If the ice sank, it would slowly fall down over top of living things in the water, and it would also not insulate water for long winters. And then finally, universal solvent. Water is used to dissolve polar things. Our cells use it exclusively as a solvent, and it becomes a huge part of almost everything that's going on in our body. Explain lake effect snow. Lake effect snow is because in the winter, the water is warmer than the air around it, and it's going to evaporate off moisture into the air. That moisture solidifies into clouds and then moves over and dumps snow on us. It takes some time for these clouds to form, so it's not going to drop right on the shoreline, but it does, drop pretty quickly geologically and geographically if you think about it. Like Kaskaska's not that far away, and it drops all of its snow, and that's why we have lake effect snow. Explain why water takes forever to boil. That's because of high specific heat. Water refuses to change temperature. It's great at modulating temperature. It takes a long time to warm up. And so when you're staring at a boiling pot of water, it's taking forever to get warm. That's because it takes a lot for the water molecule to break cohesion and to actually evaporate off and to change temperature and change states of matter. 5, explain why soapy water or soap water do not have as many drops on the penny. Because the soap is supposed to get in between the water molecules, and because soap is partially polar and partially nonpolar, it's called amphipathic. It doesn't allow water to bond to itself as well, and you can't get as big of as a bubble or drop onto the pennies, and it doesn't build up on itself very well, and it falls off and slides off, and you don't get as many drops of water on a soapy penny as you do to a regular penny. So I hope that answers that. Then we have from yesterday the water quiz. If you did not take the water quiz, you need to talk to me and email me. We're going to do a retake, and that retake is going to be a different quiz, and it's going to be something that's done at a certain time, and it's not going to be a note quiz. It's going to be just a straight up quiz like anybody else we normally would take, and because you didn't take the quiz when you were supposed to, if you didn't do it, then then you're going to take it as just a regular quiz after school, before school, no notes, and see how well you do. And then monomer versus polymer. The main idea of monomer versus polymer is that monomers are single units of things, and polymers are many units of monomers connected together. So I always picture a train. So you have train cars, which are the monomers, the actual just single train car, and then you connect a bunch of train cars together, and you get a train, which is a polymer. And so this relationship between monomers and polymers is crucial for what we're going to go into macromolecules. Every macromolecule is going to have a monomer, and how you connect that monomer together, how you connect those train cars together, is going to give you a different kind of polymer, or different kind of train, or different kind of macromolecule like carbohydrate, protein, lipid that we use in our body. So I hope that was a good review. I hope that you were understanding our work. If you need any help, let me know.